Welcome to homework.
We're going to describe the motion of a particle, which follows the curve generated by the parametric equations x is equal to sine of t and y is equal to cosine squared of t. First, we're going to find an equation that describes these parametric equations in Cartesian coordinates to graph it, and then we'll use the interval of parameterization to determine how the particle moves along this curve. So first, we can almost say that sine squared of t plus cosine squared of t is 1, but x is equal to sine of t, not sine squared of t. So we need to square t. So if we have x squared plus y, that's equal to sine squared of t plus cosine squared of t, or 1. Rearranging, this is y is equal to 1 minus x squared. So this curve can be described by part of this parabola, but x can only range from -1 to 1, so we're in a very limited frame here. The x is going to be from -1 to 1, and y is going to be from 0 to 1, which you can also see up here from the parameterization for y. So to determine how the particle moves along this curve, we're going to look back at the interval of parameterization. We're starting at -2 pi, which I'm looking over here. At -2 pi, x is going to be equal to 0 and y is going to be equal to 1. So we're starting here. And then at the next nice point to look at, -3 pi over 2, we're going to have x is equal to 1 and y is equal to 0. So we're going to end up over here, following this parabola. And then we're going to move back up to y equals 1 and x equals 0 at -pi. At -pi over 2, we're going to have x equal to -1 and y equal to 0. So it's going to keep moving along here. And by the way, this dotted line is moving along the same path that this parabola would. I'm just drawing it on the outside. And then when t equals 0, we're going to move back to our original point. And from 0 to 2 pi, we're simply repeating this whole motion. So the starting point and the ending point are the same point, and we loop around this parabola twice. And so we have completely described the motion of this